Okay, so we're going to talk a little bit about graphic communications. Okay, why it's important. Talk a little bit about views, dimensions, and sketching. So, uh, in engineering, this is a means of communicating technical ideas. So it aids in the visualization of the design that you're looking at, the communication of the design, basically letting people know, um, what the design is, as well as the documentation that is putting the final designs to paper so that it can be fabricated, marketed, all that sort of thing. Okay. Now, engineers are an anal bunch. Uh, we have definite rules, clear, precise language. So the rules must be followed. Things are as we like them, and you have to follow all these rules so everybody's on the same page when it comes to these technical drawings. Okay, so today we're going to talk a little bit about sketching. Okay, and this is just kind of a preliminary rough drawing showing the main features. And again, we base this based on the audience, right? If you're talking with another engineer, with you're talking basically to yourself in coming up with designs. If you're talking to a client, right, it's going to be different sort of information that you relay in that sketching. It's an important skill. Most of what we'll do in this class will be in computer-based CAD, okay, but sketching is an important thing, not only to understand the concepts of what we're doing in technical drawing. But it's also, again, a good way to get those preliminary ideas out to whoever it is that you're talking to. Okay, so we do this freehand, uh, use a mechanical pencil and eraser. Now, the eraser is just for mistakes. If you have specific design changes, you should actually start a new drawing so you can kind of see the path if you want to go back and look at, hey, how this evolved. Ooh, I actually liked the fourth design, as opposed to this design or whatever it is. Okay. So if you make a design change, you should actually start the drawing over. The eraser is just there if you like make a mistake, so to speak. Okay. Uh, Paper, obviously, you can use unruled, just like clear copier paper, printer paper, or if you want, grid paper can be very useful. Just depends on what it is that you like, what you prefer. Okay. Uh, Again, we're sketching here, so there's no rulers, no compasses, no triangles, nothing like that. We're just doing freehand sketching here. Again, the computer will get those nice straight, uh, uh, perfect lines for us. Okay, this is just about getting ideas onto paper as quickly and as efficiently as possible. Okay, now we're going to talk specifically about multi-view drawings and do a few sketches with that. Now, multi-view drawing is basically a collection of 2D drawings of a 3D actual object. And the way you can kind of think about this is if you have this 3D object, you can kind of surround it with a cube, right? You've got a front, a top, the bottom, side left, right, back, okay? And if you look on any side of that cube, you've got a view. Okay, and these are basically the principal views that we have here. Now, when we draw this drawing, we basically take the front view, the top view, and the right side view. And we basically unfold that box into a two-dimensional drawing. Okay, so we've got the front view, the top view, and the side view, and they perfectly align. So if you look at this bottom drawing down here of that part, okay, you see what's correct, right? You show that front view, and then right above it, again, you think about folding that top part of the box up, okay, and you get the top view, and then on the side view, you fold that one out to get that side view. Everything's perfectly lined up and whatnot. Now, again, you want to make sure that they lined up. You don't want everything just kind of, hey, I want to put it here, I want to put it there. It should look like an L, right? Front, top, right side. Okay. You don't want to do the back and the left and things like that, right? It's a very specific way that we do this. Okay. And you want to set it up just like that, aligned as well as possible. Okay. Again, in CAD, it'll align it perfectly. When we're freehand sketching, you just want to do the best you can. Okay. So there are some line conventions. Okay, and we've got the visible lines that you see; those are obvious. But we also have hidden lines. These are lines that are hidden behind a surface or something of that nature. Those are represented by dashed lines. And then we have center lines, and you can see those like on the holes here, where it's basically long, short, long dash, and it kind of shows you the center of the axis. You can see this on the top view on this lower drawing. You've got that long, short, long, and those are center lines. Okay, then we've got the visible lines. Those are the solid lines. You can see those lines that kind of uh, go from one view to the other. Those are construction lines. you're going to erase those if you put those on. Those should not be there for the drawing. Here it's just showing you that it's lined up. Okay, so just keep in mind those line conventions. These are the lines that you need to include in that. So in creating a multi-view sketch, and again, I'll do this by hand. There'll be another video for that. Okay, you want to choose your front view, choose the most descriptive, orient it in such a way that the side and the top are going to look good, give you very descriptive. Just take a couple of seconds. It's usually pretty obvious what the front view is, but you just want to set that up. Okay, once you do that, then you kind of make you kind of outline everything, right? And you kind of outline where the top's going to be, where the side is going to be. Okay. Um, Usually we're going to use three views. When in doubt, use three views. Sometimes you can get away with just two views. The rule becomes, we haven't gotten into dimensioning, we'll get to that later, but if you can dimension every dimension without breaking any of the rules that we're going to talk about, with just two views, then you can get away with two views. But when in doubt, you can always do three views. Again, front, top, side view, perfectly lined up like we got there. Okay. So once you have kind of where the views are going to go, you start blocking out those features. Okay. You want to make sure all the features line up, so on the top view, you kind of can do those construction lines up, make sure any holes line up, any outcroppings or cuts line up between the two views. You can use a miter line, show you how to do that when going through the example. Um, Once you kind of get it laid out, you can darken anything out, make sure you include any hidden lines, include your center lines, and that pretty much ends the drawing until we get to dimensioning. If you do have any construction lines, those you'll want to erase. You may have used them to just kind of make sure everything's lined up, but ultimately want to erase them. So that kind of lays out how to create that multi-view sketch. Then we need to go to dimensioning. Okay, and this is honestly probably the most important part, or just as important as the drawing itself. And this basically gives you the basic size and locations of the features. You can see a lot of things here, right? So we've got dimension, we've got things called extension lines, right? Notice we have a diameter symbol, we have a radius symbol, okay? Different things like that. So right here we've got two views of a multi-view drawing, okay, with all of the dimensions put on there. Now, one of the main things here to realize is everything's only dimensioned one time, okay? So you want to dimension each feature once and only once, and you want to avoid that over dimensioning in that, and we'll get more into that as we get into the rules. But again, whole idea is here is you want all of the features, their size and their location uh, laid out with the dimensions, similar to kind of how this looks. And again, we'll do an example of this as we go through. Let's go through some of these rules. The main rule, and you'll see this at the top, I've got two slides of guidelines. Clarity overrides everything. So if it's going to make things easier to understand, you can break a rule. That doesn't mean, usually you're not going to break any rules, but sometimes you just have to break a rule for one reason or another. And we'll get into some of those examples as we go through. Okay. Again, you want to dimension each feature only once. So take this as an example, right? We've got dimension A and dimension B, B being the overarching dimension and A being that cutout. Now, I can imply that this um, dimension in here is going to be basically B minus A. There's no need to include that. That's what we call over dimensioning, and that's wrong. We do not want to do that because what we're trying to do here is if someone's going to fabricate this or redesign it or something like that, we don't want any extra dimensions that they might get confused. Well, which one is more important? Heaven forbid, those dimensions don't add up to what you expect them to. You only want to put the dimensions in there once and only once. So you want to avoid this one over here on the right, where you have both A, B, and C, because again, A plus B equals C, so C is implied. You would only need two of these three. And again, which two you choose, well, that depends on the design. And sometimes you won't know, sometimes, it depends on if you're designing or not. But a lot of times it might be important for the overall dimension to be, 2 inches. So you'd want to put that in there rather than, each aspect of it. And again, that's not super important right now for this class, but what really is important is that you do not put all of those. Only each feature one time. Even implied dimensions should not be included. Okay, everything should be oriented to go from the bottom. This is kind of the hierarchy if you wanted how you put those dimensions in there. Basically, you want the number between the two extension lines that were drawn off of that surface, like you saw in the previous slide. But again, you want to be able to read from the bottom. You don't want to turn these, so you have to crank your head sideways to be able to read them. You want to put the dimension on the most descriptive views. So if you see here the drawing on the left, you want to put that dimension over there as opposed to on the right, because you can actually see, oh, this is kind of that outward leaning surface. You want to put that in there. It's easier to understand what you're dimensioning. So you want to put those dimensions on that view that shows it. And again, you want to choose what dimensions you actually put on there based on the function. I talked about this earlier, right? Because there's several different ways you could fully dimension something without over dimensioning. You want to choose the dimensions that are most important based on the design that you're coming up with. And that's a little tricky, whether you're designing, if you're designing the object, hey, this needs to be 1.5 inches. If you're just, looking at a drawing, you know, it's your guess. But as the drawer, you're the one telling whoever's fabricating it, hey, this is the most important dimension. Make sure you get this one correct. You don't want to avoid, you don't want to dimension any hidden lines when possible. This is one that can oftentimes get broken. A lot of times you just can't get 3 views where you're not dimensioning hidden line. But in general, you want to avoid that. Only dimension visible lines, visible features. Okay. Again, as we continue through this, keep in mind clarity trumps everything. So you're going to want to go ahead and break any rule you need to. You want to follow the rules when possible, but if you need to break those rules, clarity trumps everything. So if it's going to make it easier to understand, you go ahead and do that. So continuing on, those dimensions need to go outside. You want the object, the drawing, to be dimension free, which is to say, and again, this is one that oftentimes will get broken just because it'll just get too messy with all the dimensions. But generally, you want those dimensions outside of the object, not on the inside of the object. So again, you want to pull those out with those extension lines showing, the features and the size and the locations and things like that. When possible, you want to align and group, right? So if you've got a whole bunch of, this is a revolved piece here, so you got a whole bunch of diameters. You want to keep all those together. It'll make it a lot easier for someone that's fabricating this if they say, oh, now I go 20, 40, 50, 75 for these diameters, okay? Similarly, if you've got these different depths, relating them all back to the same point, like I have here, the 20, 40, 50, 58, 68, that way if someone's fabricating it, they can just zero their counter, say at the left side, move 20, make that dimension, then go to 40, make that dimension. They don't have to reset their counter. It's all based off the same 0 point. Can be very helpful in fabricating a part. Again, the CAD will take care of this, but the leader line should be radial. When you draw like a diameter of a circle, that arrow should go through the center. Okay, but you just draw an arrow down to it, and then up here you put the little diameter sign on there, and that's how you want to do it. Now if it's a full circle, you put the diameter. If it's a arc, right, so semicircle, quarter circle, something like that, then you're going to want to use a radius. Okay, so if it's a full circle, you dimension with the diameter. If it's an arc, it's a radius. So again, those are some of the principles. Other ones will come up as we go through the course, and you'll pick those up as we go, but those are the main ones that we want to follow as far as the dimensioning guidelines.